Let's see how to find the area enclosed by the curve y is equal to x squared plus 1, the x-axis, between x equals to 1 and x equals to 3. Now the first thing you should really do when you're given an exercise like this is try and visualize what you're actually being asked for. Now, what we're being asked for here is to find the area enclosed by the curve of y is equal to x squared plus 1, which would look something like this. Y is equal to x squared plus 1, which, remember, cuts the y-axis at x equals to 1, between x equals to 1 and x equals to 3. Not drawn to scale here. So essentially, we're being asked to find this area here, which I'm hatching in purple. To do this, we're going to have to use calculus. And we're going to use a two-step method here. The first step, which we'll call step 1, is going to be to find the antiderivative. Now remember, the antiderivative function of f of x is a function which we'll write capital F of x, which is such that if I differentiate capital F of x, I fall back on f of x, where f of x in this case is equal to x squared plus 1. Now, given that f of x equals to x squared plus 1, the antiderivative, capital F of x, will be equal to x cubed over 3 plus x plus some constant c. That's our step 1 done. We have the antiderivative. Our step 2 is to calculate f of 3 minus f of 1. And this is equal to the definite integral between 1 and 3 of f of x dx. In other words, that's equal to the definite integral between 1 and 3 of x squared plus 1 dx. In this case, this will be equal to x cubed over 3 plus x between 1 and 3. Now we ignore the constant of integration here, because since we're subtracting one antiderivative from the other, the constant of integration will just disappear. So, evaluating this will lead us to 3 cubed over 3 plus 3 minus 1 cubed over 3 plus 1. This leads us to 27 over 3 plus 3 minus 1/3 minus 1. 27 over 3, of course, is 9, and 9 plus 3 is 12. So we have 12 minus 1/3 minus 1, and we can quickly see that that's going to be equal to 11 minus 1/3, which will be equal to 10 and 2/3. And remember, these are units of area. So there's a golden rule here that you really need to remember, is that the definite integral between a and b of f of x dx is equal to the difference of the antiderivatives, capital F evaluated at b, minus capital F evaluated at a. And the fact that we're subtracting one antiderivative from the other is what justifies the fact that we get rid of the constant of integration when we are calculating definite integrals.